All right, this lesson is for anybody that, again, was absent or just need a refresher on factoring difference of perfect squares. So let's go ahead and do the warm-up, and we're going to do the FOIL method. So we're going to take k times k, gives you k squared, and then k to the 5 gives you 5k. And now you have to do the inside or the next term. So then you're going to take negative 5 times k and negative 5 times positive 5, which is negative 25. Now you always have to collect like terms. The only two that have the same terms are right here. They actually cancel out. So you're left with k squared minus 25. All right, on to the next one. So same concept. We're going to take the 5 m to the 5m. 5 times 5 is 25. M times m is m squared. And then you're going to take the 5m to the 1, which is going to get you 5m. And then the negative 1 to the 5m, it's going to do negative 5m. And then negative 1 to 1, which is negative 1. Which the next step is to cancel, or collect like terms, sorry, but they do end up canceling right here, leaving you with 25m squared minus 1. Now, real quick, if you were to look down on the page, you should notice that our two warm-up problems up here are very similar to these 4 problems. And there's some of the similarities are that they all have 2 terms, okay? And that's called a binomial. Binomial. All right. The next thing you should notice is that on every single one of these problems, ignore that, they're subtracting. Okay, so those are the 2 most obvious. So they're subtracting. Okay, and here's the third thing that you should notice, hopefully, and if you don't, that's okay. But every single one of these terms can have, you can take the square root of them, okay? Not so much this one. Okay, number 2 is kind of a weird case, but you can take the square root of 81, and that's 9. Take the square root of b squared, that's b. Square root of x squared is x. Square root of 100 is 10. Square root of a squared is a. Square root of 4 is 2. Square root of 25 is 5. Square root of m squared is m. Square root of 1 is 1. Okay, and then so on. So you can take the square root or perform the square root. Okay, I'll just put parentheses around that, or quotations. So these are the 3 rules you have to follow. You have to follow for this to work. If any one of these fails, then this answer is prime. Okay, so you have to make sure it's an actual difference of squares. So these are the rules that I'm saying right here, and it's written as like subtraction sign, and you must be able to square root both terms. Okay, both terms are saying that there's 2. Okay, and the rule states is that you have a minus b and a plus b. So essentially what you're doing is square rooting these, and then you just have a parenthesis with subtraction sign and a distance sign. So, and you can check your work for these, but we're not going to, just to save some time. So on number 1, you ask yourself, are there 2 terms? Are they subtracting? And can you take the square root of both of them? And you can. The square root of a is a. What you're going to do is you're going to write that as the first term, and the square root of 4 is 2. And then you just write a subtraction and addition sign, and that is the answer. If you do want proof of how this works, you can notice with the warm-up that this is exactly the same setup as how we're factoring here, and the answer looks exactly what we're doing here. So we undid the factoring and went back to the simpler form. Now moving on to number 2. Okay, you can subtract. There's 2 terms. You can take the square root of n squared, but the square root of 64 is not a perfect square. So it fails rule 3. So for that reason, if it fails any rule, it's prime. Okay. Now if this was 64, it'd work because the square root of 64 is 8, but it's the square root of 62, and that is not a perfect square. And this whole thing is called the difference of perfect squares. So you're subtracting 2 perfect squares. Okay. Moving on. You have x squared and 100. So when subtracting, there's 2 terms, and you can take the square root of both of them. So the square root of x is x. And the reason is because square roots and square cancel. It's kind of like adding and subtracting. They cancel each other out. Multiplying and dividing, they cancel each other out. Square and square rooting cancel each other out. So like if you have cube roots and something that's cubed, which is a third power, that cancels out. So it just cancels out the square and the square root, leaving you with this x. The square root of 100 is 10. 10 times 10 is 100, so that's what we're asking. And that's what you write, and then you get the negative and the positive. So that equals 10, just to write that there. Okay. I'm going to do 4. And then I'm just going to do the odd from here on out, just to keep this video kind of short, and hopefully you get a hang of it. Again, if you don't, though, feel free to comment somewhere or get a hold of me or email me, and I will do the rest of them or answer questions. Okay. Now, here's the important part. When you do something where the variable is second, like these two, leave it as is. Follow the same rule. Say, okay, are there 2 terms? And there are. Is it subtracting? Yes. Can you take the square root of 81? Yes, it's 9. If 81's in front, you have to keep it in front, or you have to do some sign changing, and you have to basically factor out a negative. It is a lot easier just to follow it as is. So the square root of 81 is 9. It's the first term. I'm writing it first. The square root of b squared is b, because the square and the square root cancel out. And that's your answer. Okay. Moving on to example 5. Okay. These are 2 terms, but they're not subtracting. Since they're not subtracting, not sure where I went from capital letters to lowercase, but anyway, since they're not subtracting and it fails one of the rules, it's automatically prime. Okay? So what I want you to do is attempt number 7. We haven't done something like it quite yet, but it's not really that different than what we've done. So let's see how far you can get on 7 without any help. So go ahead and pause the video now. All right, now that you pause the video, it's time to go through the process of how we got this answer, or unpause the video, sorry. There's 2 terms. They're subtracting. You can take the square root of 16, and you're allowed to do this, the square root of a squared, and the square root of 121. So you're allowed to think of them as separate entities or terms, and that's okay. You can think of it as an entire square root, but it's still the same mathematical process. So you're going to ask yourself, what's the square root of 16? And that is 4. The square root and the square cancel, so it leaves you just a. And then you write 4a over here. And the square root of 121 is 11. So that's your answer. Since a is to the first power, you can't go any farther. Okay, that's prime, so that's your answer. Okay, moving down to number 9. It's a little bit different. We're still asking the same questions. 2 terms, yes. Subtracting, yes. Can you square root? Don't know. Okay, so let's talk about this k to the 6th power. Now, k to the 6th power is the same thing as k squared times k squared times k squared. Okay, and we're doing this whole square rooting thing. So we're square rooting this. Or you can think of it as we're square rooting this term separately, this term separately, and this term separately. Remembering that 2 and 2 and 2 all get added up, and that gives you back to that 6. We already said that the square root and square cancel, so that would just leave you with k. That would leave you with just k, and that would leave you with just k. Okay. We have 3k, so it's k cubed, and voila, we have what we need with that. So what you're essentially doing, only with the exponents, is dividing by 2. So you're saying how many pairs is made out of the 6? Well, there's 3 pairs. All right. It's kind of like 16. What pair multiplied together gets you 16? Well, 4 and 4 multiplied together get you 16. So that's what you're doing when you're square rooting. You're asking what 2 same number multiplied together gets that answer. Okay? All right, let's go to the next page. All right, so these are dealing with more with greatest common factors. So my hint to you is that there's a coefficient other than 1. You probably need to ask yourself, is there a greatest common factor? Coefficient other than 1, coefficient other than 1, coefficient of 3, 80, 15 will be a little questionable of what that is since there's no coefficient other than 1, and this has a coefficient of 16. So in all these you have numerical values, not sure about 15 still, that you have to factor out. So always look at the smaller number to figure out what you can factor out of the bigger number. So 2 is prime, which if it's prime number, it's typically going to be what your greatest common factor is. And it is because they're both even. This has a variable, this does not, so there's no variable to factor out. So we're factoring out 2, which means we're dividing everything by 2. The 2's would go away, leaving you with n squared minus 36. Now the reason we're not done factoring is because of this n squared right here. If there's an n squared, you always have to ask yourself, or an x squared, anything to the second power, you have to ask yourself, is there more to do? And there is. And this should look familiar to what we just did. So we have 2 terms, they're subtracting, and you can take the square root of both of them. So we have more to do. Now this 2 just kind of follows along. I like to say it's like the third wheel in the situation. Okay, it just drops down. Okay, it just it's there, but it's not really doing a whole lot. So only factor or focus on this factoring. Let the 2 just drop and keep going. So to factor this, you ask what's the square root of n squared, which is n, and the square root of 36 is 6. And that's your answer. Okay, so not too bad. Okay. Now when there's larger numbers, it does get a little bit more complicated. Okay, so I would like for you to try to figure out what the greatest common factor is here. Okay, ask yourself, is there a numerical greatest common factor? And is there a variable? Okay, so go ahead, work on this problem, and then start it if you get stuck or once you get done, right? So pause the video now. All right, now that you restarted the video, let's go over what the greatest common factor is. So since this ends in 0, this ends in 5, we know that they're both divisible by 5. So let's think about this. 80 divided by 5 is 16, and 120 divided by 5 is 25. So 25 and 16 are both perfect squares. So we're on to something there. So 5 numerically is the right greatest common factor. And then we have to ask ourselves about these variables. Well, they have at most 2 in common, so that's what we're going to take out because we're doing the greatest common factor. And then you're dividing everything by 5n squared. Okay, 80 divided by 5, as we said earlier, is 16. N to the 4th divided by n squared is n squared. 125 divided by 5 is 25, and the n squareds would go away. Okay. Now this we can't do anything else with, okay? It's just going to sit there. That's the greatest common factor. But since this is squared, we probably have to keep on going. So ask yourself this when there's 2 terms. There's 2 terms, they're subtracting, and perfect square technically, perfect square. So that means we can continue factoring on using this method. So we're essentially square rooting everything. So square root of 16 is 4, square root of n squared is n. Square root of 25 is 5, and you put your negative and positive sign, and you're done. So it's not too bad. And you're done because this goes to the first power. And once you get to the first power, unless there's a numerical greatest common factor, yours should be done. Okay? Now, number 15 is different than all of these on here. It has a coefficient of 1 both here and here. So technically the greatest common factor numerically is 1, but we don't really have any use for that. Okay, it doesn't do anything for us, so we're not really going to use that or write that down. Okay, so then we're going to move on to variables. You have 2 m's here and 1 m here. So that means they have 1 m in common. They have an n here and an n here. They both are to the first power, so they have an mn in common. So we're dividing everything by mn. The n's would cancel because they have the same amount, but only 1 m would cancel on the top because of this one on the bottom. Okay, this would cancel completely, and you get minus 1. All right, so we took out the greatest common factor. We're left with this m minus 1. M minus 1 has a highest power of 1, which means this right here is done. So you actually can't factor this any further, okay? I just wanted to throw an example in there where you didn't take this second step a step farther. So you have an example of what's going on. It's not prime. This is prime. This is prime. But together, that's the factors of the original. So that's the answer. All right? Hopefully that helped. If you have any questions, just let me know. All right? Thanks. Bye.